Hello, it's Scott Manley here, and today I want to bring you a 360 video about wormholes, because we've seen wormholes throughout science fiction and movies and TV shows, but we never get to really look around. So I decided to go deep into the math and write a ray tracer which would actually model the trajectories of light rays around a wormhole. So this is an example of a wormhole near the planet Saturn. Obviously, this is a nod to Interstellar. In fact, I used the same mathematical formulation that Kip Thorne and Double Negative used for that movie. To give it the look they wanted for the movie, they could adjust the diameter of the wormhole, the length of the constant diameter throat, and the amount of curvature around the mouth, which is defined by a mass parameter. So going in, there is a mouth, which is sort of the circular area we see, and then when we're inside it, there is a section called the throat, which is constant diameter, and we see rings of light that have spiraled their way around the hole. So as I said, this is designed with visual effects in mind, with a lot of things you can mess around with. The first wormhole that was documented in literature that was traversable is the Ellis wormhole, which is also known as the Morris-Thorne wormhole. On that you can adjust the diameter, and I guess you can also add a constant width throat in it. So yeah, I've just created one here and we're going to traverse it too. This doesn't have the tweakable mass limit, it just has a very wide range. Now Morris and Thorne looked at this and they came up with actual solutions for how you would distribute mass and material in the universe, and of course they found out that you needed exotic matter, that is matter which in some reference frames may have negative mass. So I should make it clear that while these are physically correct traversable wormholes, there's no evidence that wormholes actually exist in reality, and if they did exist, we don't know how to create them because they require exotic matter which we don't know exists. So anyway, I want to now play with some of those sliders. Here is a new wormhole. You can see it's distorting gravity. It has a mass of 0.1, a radius of 1, and a length of 1. Also, you'll note that it is spherical. So wormholes are spherically symmetric, which means whatever direction you look at them, they are a sphere. So now what we're doing is increasing the length of the throat. And as you see, as we raise that length, we start to see more and more rings as the light echoes around the inside. I'm now going to plunge down into the middle of the hole. And yeah, you can see these rings of light, but you know what, instead of going all the way through, what I'm going to do instead is now collapse the wormhole back to a 0 length, so you can see the difference as we shrink it down from a length of 10 all the way down to a length of 0. All that ringing disappears, and now we are sitting on the doorstep between two different universes. So now let's pull back and adjust the mass parameter. The mass is 0.1. We can raise that up quite a lot. In fact, we can raise it up by a factor of 20. And as we raise it up, it will adjust the amount of lensing here. Now, many people call this gravitational lensing, but that's not strictly true. This is spatial lensing. There is no gravitational component here because of the way the metric has been described. There's actually no gravitational acceleration on this object. But because space is so warped around it, light gets warped around it, and of course, objects will get warped around in exactly the same way. If there was a gravitational component, then physical objects and light would follow different paths, and also we would have enough tidal forces that we would probably tear anything apart. So typically traversable wormholes have no gravitational effects. So now we're going to roll down into the wormhole again, just so you can see what it looks like. We're just going to move right through to the other side, and then once we're on the other side, you can look backwards, by the way, because this is a 360 video. I'm going to tweak the mass of the wormhole down to essentially 0, and this removes all the lensing. Funnily enough, by reducing the mass, it actually increases the curvature of space, because the high mass makes the curvature spread over a wider area. The low mass makes it almost exactly attached to the surface of this sphere. So what it looks like is a sphere. And as we move through, there's no transition or anything here. It just looks like a planet right now, but as soon as we start orbiting it, you'll notice that the textures are basically moving the opposite direction. What we are seeing is not an object with a surface, we are seeing a portal to another universe through that sphere. This is one thing that a lot of sci-fi with wormholes will ignore. Things like Deep Space Nine, they don't really show you the backside of the wormhole. Well, yeah, the backside is exactly the same as the front side because it's a sphere. So to give you a better idea of where the surface is, I'm going to tweak up my graphics and add a grid over the surface of the wormhole. This is at the mouth. There is also the interior throat. So we have a yellow sphere on the exterior, and there's actually an inside here on the throat, and now we're through to the other side. So you see I've got 4 different colors of grids for the spheres around the inside or the near side and the far side, and you've got inside versus outside shading. So I'm just going to come back through, and this is 360, so you can move the camera around. I'm going to pause it in the middle, take a look to the left and the right. It doesn't look like we're inside a sphere. It actually looks like we are between 2 planes, because the light rays just go on in a circle and they keep looping around. The wormhole has a finite width, but there's no wall or anything that you'll bump into. Instead, if you go in with a spacecraft which is too big, then one side of your spacecraft loops around the wormhole and crashes into yourself. So I'm switching viewpoints here to show you what happens if you try to go sideways. So this is just outside the wormhole, and we're going to the side. You can go in any direction and you will essentially orbit around the surface. Now it looks flattish because when you're close to a sphere, then it looks like a flat object. But the cool thing is now we can actually go just inside the wormhole, and sure enough, we can now see the surface above us, but we can also see the surface below us. And at this point, we are exactly in the middle of the throat. And you'll notice that both of these things look like they're going in the same direction. It looks like we're sandwiched between 2 parallel planes, but we know from the outside that plane is actually a sphere, and the plane below us is actually a sphere. So it's only because space is warped in the way it is that they both look flat to us. And of course, so now if we continue to move through the wormhole, that's downwards, and we move down through this sphere and have both of them above us. And of course, this sphere is now curving the opposite direction from the one above us, but it doesn't matter, we can't see it because we are so close to the surface of this wormhole. So yeah, wormholes are weird. There will be a part 2 to this, which is not a 360 video. It'll explain how I did it and a little more about what you're seeing here. I'm Scott Manley. Fly safe.